Hello, my name is Michael Burton, and welcome to AMAR Astrobytes, the weekly show from the AMAR Observatory and Planetarium, where we bring you stories about astronomy in bite-sized chunks. Today's Astrobyte continues with our tour of the solar system. We return from the frozen comets of the AOP cloud at its edge to its fiery center, the Sun, our local star. The Sun is by far the dominant member of our solar system, making up 99.8% of its entire mass. The Sun is the bringer of life to our planet. It is the ultimate source of the energy that drives the ecosystems that sustain us, from the day-night cycle that forms the basic rhythm to our life, to the seasonal cycles that drive the life cycles of biological systems, to the climatic zones that determine what kind of life can flourish. The Sun is the conductor for life on planet Earth. The Sun is also our local star, a ball of hot hydrogen gas whose engine is driven by nuclear fusion in its core. Let us take a closer look at our local star. This yellow ball that we see in the sky each day shows us the Sun's photosphere. It is where the light from the Sun escapes from, to then arrive at the Earth 8 minutes later. It is not a solid surface, but simply the place where the Sun becomes transparent, like reaching the edge of a bank of fog. Here, the temperature is about 6,000 degrees centigrade, where the spectrum peaks in the yellow, hence the Sun's colors. Notice the blemishes on the photosphere. These are sunspots. We now zoom into one of these sunspots. A typical spot is about the size of the Earth. The central umbra looks dark because the temperature is about 1,500 degrees cooler than the surrounding photosphere, so emitting relatively less light. Strong magnetic fields are suppressing the flow of heat from the Sun's interior. This is transported in convection cells, as can be seen in the dappled pattern around the sunspot. The number of sunspots varies in an 11-year-long solar cycle. At minimum, few, if any, spots can be seen. At maximum, many giant spots are seen spread across the face of the Sun. Above the photosphere lies the tenuous chromosphere and then the corona, the Sun's atmosphere. Here we can see solar flares, powerful storms that are the Sun's weather systems. Driven by flows of heat and convulsions in the magnetic field, they release huge amounts of energy and particles. The latter stream out of the solar system as the solar wind. This is a solar prominence, a loop-shaped bright filament of gas, extending out from the photosphere into the solar corona. They can rise to hundreds of thousands of kilometers above the chromosphere, driven by magnetic forces. The white circle marks the size of the Earth. See how small it is in comparison. Prominences are major eruptions in the Sun and can give rise to coronal mass ejections, where vast numbers of particles stream out from the Sun at speeds of hundreds of kilometers per second. They can result in violent space weather if they encounter the Earth, damaging satellites in orbit and even knocking out power grids. The energy which creates these titanic outbursts is produced in the core of the Sun by the process of nuclear fusion. In the Sun's core, temperatures exceed 15 million degrees, hot enough for hydrogen to be converted to helium. This process involves protons, the nuclei of hydrogen atoms, colliding and bonding together to form a helium nucleus. This fusion process takes place in several steps, involving the temporary formation of nuclei like deuterium along the way before ending up as helium. The mass of each helium nucleus is slightly less than the mass of the 4 protons from which it was formed. The difference is converted to energy, the amount given by Einstein's famous E = mc² formula. It is produced in the form of gamma-ray photons. These work their way out to the Sun's surface in a random walk, taking tens of thousands of years to complete, while degrading to lower energies as they do. Once the photons reach the photosphere, they can escape. This is what we see as a brightly shining star. Every single second, about 4 million tons of matter is converted into energy through nuclear fusion. The Sun has been doing this for nearly 5 billion years now, and will continue doing so for as long again. This is the daily life of our Sun, our local nuclear fusion reactor. Thank you.